Hello and welcome back. Let me take you through some R script examples for generating control charts. First, let's call up our example scripts here. Now, to generate control charts, you need to have a package installed called QCC, which stands for Quality Control Charts. So let's do install.packages QCC. Now that will actually load it from the internet and install that for you. Library QCC command will actually make sure it's being sort of accessed and available for our workspace. And there's just one setting I'd like you to change, which is the alarm for runs, to change it away from 5, which is the default for this package, to 8, which is what I'm using for this course. So that's a QCC.options, setting the run length to 8. Now let's go through an example here with the chemical reactants. Now the data for this is the temperature and the temperature edge commands here. But let's first load in the raw temperature data, which I've actually got a bit further down, because I want you to have a look at it first. So the raw data, which is the temperature one, and we'll just sort of view it as well. So what we have here is that we've got a whole lot of samples taken, and the temperature of this thing that we're measuring sort of collected here under the data. So it's got all the different samples and the temperatures. Now, if we're doing an eye chart for this, then the first thing we normally do is generate an MR chart in terms of process. Now, one of the tricky things here is that the R as a package and the QCC, package in particular, it doesn't generate MR charts and eye charts, so we need to use a little bit of we need to fool it into generating it. So we'll do this two ways. The first way we'll do it is which is the easiest way, is that you sort of resort this data. Perhaps use a spreadsheet to do it. Is the easiest way if you're not confident with R. So use a spreadsheet to put the data side by side, but you want the temperatures to be lagged, because what the moving range chart will tries to do is sort of check what's the absolute change from one sample to the next. So a way to sort of get this working is you put the adjacent temperatures just next to each other in the spreadsheet. And I've done that for you in the temperatures.adjacent file. So let's go back to that file up here. Okay, so let's load up temperature adjacent and we'll view the data. Okay, so what I've done here is sort of put those temperatures here. So I've got rid of the first one actually. So 7.52 ends up being the first one, and then the lag of that one, the minus 543, is that temperature 2. So this is sort of the current one and the previous one. The current one and the previous one, which is the one from there. The current one and the previous one. Now, if in R we then generate an R chart based on that data. If you remember an R chart, I'll just copy and paste that in. An R chart plots the maximum minus the minimum value of the maximum minus the minimum value. So by putting the two sort of adjacent temperatures next to each other and treating it as a sample or subgroup, it actually will trick it into generating an MR chart. Okay, because if you do the maximum minus the minimum, that will give you the absolute difference between two adjacent temperatures there. Okay, so to do an MR chart using R, using the QCC package, the easiest way to do it is just you put your adjacent values next to each other as two different columns, and the easiest way to do that is just in a spreadsheet, and then just generate an R chart like I'm doing down here. Okay, so that generates the MR chart. Let me just sort of describe this. So QCC is going to generate a quality control chart. It's reading from the temperature _ adjacent data frame, which is what we created over here. It's an R chart that we're doing because we're sort of fooling it into doing an MR chart. We're adding statistics there. That's the center line, standard deviation, lower and upper control limit numbers here. So that's that. The X label is the sample, and the title is the MR chart for temperature. Now, one problem is that this first data point is labeled as sample 1, but that's actually wrong, because if we look at our raw data, 7.52 is actually sample 2. So we need to, so we've effectively ditched the first data point because we need a sort of a lag in there. So we need to sort of do the absolute value of the difference between these 2 points. So one way to correct for that is to just generate a new set of numbers for the labels. And I've just done that here. So if we create sort of this label command here, so label variable, I should say. So if we just create a sort of a variable called lab for label, and what we do is we just I've grabbed it here just from the temperature sample file, the numbers 2 to 40, and that's going to generate sort of that 2 till numbers from 2 to 40. Okay, so I just grabbed those from the original data file. Then, if we regenerate this using the commands here, the command here. Okay, notice what we've done is the labels here we've set to lab, and I've got that here. The labels for the x-axis is set to this new variable lab 2 to 40. Okay, so you'll see that the first point here is actually labeled 2 rather than 1, which correctly matches up with our data. Okay, so that's the MR chart. Now that we've done the MR chart, let's get it to generate an I chart. Now, as I mentioned before, it doesn't sort of, the QCC package doesn't really like I and X bar charts. So let's fool it into doing one. And the way to fool it into doing an I chart is called an X bar 1 chart. Now, X bar means it's the plotting an average. An X bar chart is plotting an average of a subgroup or sample. The X bar dot 1 is a special type of the X bar chart where you've got a sample of 1. Now, last time I checked, if you've got a sample of 1 and you're plotting the mean of that number, it is just that number that you've got. So this X bar 1 chart is actually an I chart. Okay, so if we do the I chart for temperature deviations here, that's plotted it for us. So you've got this command here, QCC, for the quality control, grabs the temperature data frame, grabs the temp number variable within there. So it's grabbing temp here. It's adding some basic statistics for the center line, upper and lower control limit down here. X label, I just put sample number, and the title is the I chart for temperature deviations. Okay, and then that's the end of what we need to do for that exercise. So we'll just sort of clean up our workspace. In fact, we just need that second one. Okay. Okay, so we've got rid of those variables and we can sort of close these charts as well. Close all those. And I might press Control L and clean out the console too. Okay, we'll get rid of temperature adjacent, and let's move on to the next example. So we've got a chemical reactant here. Okay, now here again, we're sort of going to do I and MR charts. So firstly, we need to require that QCC is loaded. We've already loaded it up though, so I won't do that. And we'll load the data, sort of the research data and the research adjacent data. Okay, so what we have here is expenditure on some research in sort of thousands on a per month basis. So 21,200 spent, 33,400 spent on a per month basis. And again, just to make it a bit easier on ourselves, I've just created these sort of lags from sort of one sort of next to each other. So, okay, so notice whenever you do an MR chart, you sort of lose the first point because you don't know the one previous to that. Okay, so we sort of start with the second one, 33.4. And then you put the 21.2 adjacent to that, and you want sort of 33.4 adjacent to that one. So that's what I've done here. It's like you just sort of grabbed it and sort of moved it down one to create that lag there. So I've given you the two different versions. Now, again, with an MR chart, because the labels stuff up, we're sort of starting with a second data point. We're just going to create a lab sort of variable there, which just grabbed the month numbers from 2 all the way up to 24. Let's do our MR chart. So again, we'll fool it into doing an MR chart by using an R chart, but using the adjacent values next to each other. Okay, so that one's using these adjacent numbers and is plotting the maximum minus the minimum, which is the same as the absolute value of the difference. Okay, so we've got that. So MR chart done. For part B, let's plot an eye chart, and to do that we do the xbar1 command. Oops, keep doing that. So we've got the eye chart plotted here. Okay, we don't sort of see any particular violations here of the 3 sigma control limits. It's all looking pretty good. Now, one of the assumptions of an eye chart is that your individual data follows a normal distribution. Now, often in real life it doesn't, which is why you often have to do X bar charts to take advantage of that concept of the central limit theorem. But let's just check this visually by having a look at a histogram. Okay, so here's what a histogram sort of looks like of the individual data. Now the key thing to notice here, look at the numbers here. It's sort of 1 in this bin, 4 in this bin, 5 in this bin, sort of 8 in this bin. The numbers are pretty small here, so just be careful. Don't expect to see a perfect bell-shaped curve here and say, well, therefore it's normal. What we're actually looking for is evidence that it doesn't follow a normal distribution. Okay, so this one's sort of, it's not awful. It's not looking perfectly bell-shaped, but you're not seeing a massive tail at one side. You're not seeing it massively skewed in any direction or extreme outliers. So that could indicate that it's actually not too bad. And remember, the way sort of to look for it is that the default situation is to assume it's normal. And you're looking for evidence that it does not follow a normal distribution. Okay, we can also do the performance analytics. Now, did that actually load? Yep, so it loaded it correctly. And do a box plot of this as well. Now again, for evidence that it doesn't follow a normal distribution, you look for evidence of like outliers and skewness. And you're looking for some symmetry in the tails too. So notice here the mean is actually quite close to the median. Okay, so that's an indication that it's reasonably symmetrical. If it's sort of a long way over, that's a bad sign. The tails are sort of reasonably similar in length, and there's no sort of extreme outliers on one side. So that indicates there's some visual indication that there's no evidence here that it's significantly different from a normal distribution. So, and I know that's a double negative, but when we get onto hypothesis testing, you'll understand why I expressed it that way. In other words, it looks okay. Let's not worry about it too much. Now, we don't focus on hypothesis tests for testing for a normal distribution in this course, but there is a way to do it. So just for advanced students, we can run a Shapiro test here for evidence that it doesn't follow a normal distribution. And if this p-value here is less than 5%, then that is evidence that it does not follow a normal distribution. So if the p-value here is greater than 5%, it's like, yeah, let's relax. It's sort of, there's no evidence here that it doesn't follow a normal distribution. So that's a proper statistical test for it, and it sort of reinforces what our eyeballs told us by visual inspection of the histogram and the box plots. That's all we need to do for that one. So let's, I'll just type it, remove the list equal ls brackets there, and that removes it. So it cleans up our all our data frames over here, so it gets rid of them. Now, exercise 3 here, we've got an example of some IT service performance. So let's load up the data. Okay, so we've got it loaded here. Let's also view it. We can also do actually by just clicking these buttons here. So let's just click those buttons there. Okay, so we'll get rid of research. So we've got IT, and we've got IT in adjacent data as well. Okay, so because we're generating an MR chart, let's make sure the labels going to be right. So again, let's create our lab variable to start at 2, because we're not going to be plotting from the first data point because we need that lagged version of it. We're doing an our MR chart here, and we've got some violations of the upper control limit here, which indicates that there's some pretty significant jumps from one particular sort of data point to the next, which indicates something unusual has gone on, and there's some special causes present. There's some unusual cases present that need to be investigated. Okay, now at this stage, I'd like to show you we've been doing a bit of a hack method here to sort of do these sort of MR charts by sort of using a spreadsheet to create that lagged variable. So for advanced students, let me show you how to do this properly in R at this stage, now that we're sort of up to the third example. So I've got the code for it here. So what we're going to do is sort of create this, the IT, create this one here. What I'm going to do is I'm going to create this one solely in R from the raw IT data without going into a spreadsheet. If you're not comfortable in R, don't worry about this. Just doing it in a spreadsheet is the easiest way to sort of go and copy and paste it down. But if you are reasonably confident in R at this stage, or you just like this stuff, then as I hope that you're doing, then this is the code to do it. So I'm just going to copy this in, and I'll explain what it does. Okay, so what we're doing here is we're creating this new data frame called sort of IT adj2, so as opposed to that first one that we created. And we're going to sort of create a matrix. So a matrix is sort of, you've got columns and rows. And what we're going to do here is we're going to sort of create that, and it's going to be drawing it from the IT data frame and the hours variable, which is sort of IT data frame, the hours variable. And the particular numbers that values that we're going to be grabbing is everyone from 2 till the end. Now I could just go 2 to 36 here, but I wanted to give you a bit of a better way to find out where it ends. So rather than just typing in 36, is to use the length command. And that length command in here sort of looks for IT data frame hours and just counts how many rows there are, how many data points there is in that particular one. So it'll actually sort of return the value 36 here. So the length of this particular one, well, it's 36 values is the length, it's the count. Okay, so what this is going to do is sort of grab all of the values, the temperature values from 2 till the end, which is 36. So just imagine this as being the end. And then what it's going to do is sort of create this as a matrix and bind sort of the two vectors together, the two columns of information together. So the second column, what we want is the same variable, which is the sort of this IT hours one. But instead of it being 2 till the end, what we wanted is from 1 till 35. And so what I've got here is selecting the numbers from 1 till the end minus 1. So given that sort of there's 36 in total here, if we go minus 1, that'll take us to 35, which is what we want. Okay, now the number of columns we're giving it is 2 for this data frame, just to sort of set it up. And if we do that, we've created that there, and if we have a look at it, that's what it created, sort of V1, V2, okay? And sort of notice 29, 23, 29, 23. So it's sort of created those, and we'll sort of go all the way down to the end, 20, 28, and we've got 20 and 28 there. Okay, so we've created it. Okay, now it'd be also nice to actually name the columns here. So, okay, so the way to name the columns is to use the col names command. Okay, so rather than V1 and V2, which isn't particularly helpful here, let's give them proper names. So we're going to use column names. We're taking the IT adjacent to data frame, And we're going to name the first column to be hours 1 and the second column to be hours lag. So let's do that. Okay, now we need to sort of redo that to see the results. But if we do it there, then hours 1 and hours lag. Okay, so we've now got it sort of looking the same as the one that we created in the spreadsheet. Okay, now that's getting pretty tricky. So, as I mentioned, if you're not sort of very confident in R, what I'd suggest you do is you just set up your data in a spreadsheet, and then sort of bring that in, sort of save it as a CSV file, or is the easiest way, and then you bring that in manually yourself. Okay, so we've done our MR chart, which looks exactly the same as the previous one that we did, which indicates that we're doing something right here. Okay, if we're plotting the X bar chart here, we're going to just grab the quality control chart, sort of QCC function. We'll grab the IT data frame and we'll just plot the hours. So that's the hours from the IT data frame. And we can see here that there's a violation of the upper 3 sigma control limits here. Okay, part C. Now, because this appears to be a special cause, 24, and it was actually it was a problem in the MR chart as well around this time as well. So what we're going to do is, as part of this question, what you need to do as part of this question is remove that data point at 24 because it appears to be a special cause. And if we're in phase 1 and we're trying to sort of stabilize our charts to work out what's business as usual, that data point needs to be removed. Now, one way to do that is to, if you're not confident in R and managing the data in R, is just open up the data in a spreadsheet and just manually remove that row in your spreadsheet. And that's what I've done for you in IT services cleaned there. So let's load that up. Okay, so I've sort of removed that. So you just remove the row in a spreadsheet. And you can see that we've removed the row because the sample jumps straight from 23 to 25 there. So you can actually see that it's been removed there. And we've got the adjacent file as well, just so we can plot an MR chart now. So let's sort of do that easier version first. Excuse me, sorry. So let's do the create our labels. Okay, lab 2. Generate the the R chart, MR chart. For that, and that's got rid of that that problem with the big jump, which is good. And we can also generate the eye chart from that as well. Now, I also, for the advanced users, I wanted to also show you how to sort of remove a data point using R. And the way to do that is actually nice and easy. So it's to use this. It's to go, well, let's create IT and we'll call it underscore clean 2 for this data frame. Go to the IT, the IT data frame and remove the 24th row. That's what that minus C does, 24. It's going to remove the 24th row. Okay, so let's sort of do that. Boom. Sort of creates that. IT clean 2. Let's go down to 24 and go, oh, have a look there. Sort of 24 is gone. It goes straight from 23 to 25. So personally, I think that's a much easier way to delete a particular value rather than sort of reopening it up in a spreadsheet, which is a bit messy to do. Okay, now to create the adjacent, then you can go through the process that we did before. So I've given you the sort of the process, the code here. Okay, so if we wanted to sort of create the adjacent file ourselves, again, if you're not confident with code, this starts to look a bit messy, but what we're doing here is creating a matrix with 2 columns and 35, however many, 35 rows. Okay, we're binding together the the hours variable from IT cleaned that we just created from the second data point to the end, and next to it putting the same variable from 1 to the end minus 1. So that will create that lagged variables. And there's 2 columns in that matrix that we're creating. Okay, so that sort of creates it, and we can sort of see it being created here. Okay, 29, 23, which should hopefully be the same as the IT, the one that I did manually, 29 and 23. Okay, it's still got those horrible headings though, V1, V2, so let's give it some proper headings. It's a column names command. Okay, there's that one, so let's have a look at it again, and now we've got it looking correct. Okay, and we can generate our MR chart from that. So that's a proper way to delete a particular data point as we're trying to stabilize our control chart to work out what is business as usual. Okay, now let's have a look at the eye chart. We'll create some labels here. I've just called it label 3. Okay, so we want the labels to be numbered correctly, especially given that it's not going from 1 to 3. We've actually skipped one of the data points, so we need to make sure that we're using the correct labels. So that's what I did there, create that lab 3, and I just grabbed the sample number from that file. If we do the eye chart now, we can see we've got rid of those that breaches of the control limits. And notice you can sort of see the skip here. It goes from 21 to 23. You'd expect that to be 25, but because we removed the data point in there, it goes to 26. So. Okay, with an eye chart, we need to check whether if there's evidence that it does not follow a normal distribution. So let's have a little bit of a look at a histogram. And again, it's not going to look perfectly bell-shaped, but it's not too ugly. Let's do a box plot to do a visual inspection, and what we're looking for here is evidence that it doesn't follow normal distribution. So we've got the sort of the mean being really close to the median here, which is sort of a good sign that indicates that there's much skewness. But we do actually have an outlier that's miles out here. Now that isn't so good. That's not good at all, sort of having one that's sort of so low there. Okay, so that could be a bit of evidence that it doesn't follow a normal distribution, but if you look at our control charts from previously, it does fall within 3 standard deviations. It's actually very close to it. Okay, that's close to being a problem down there. Now there's only 36 data points. You'd expect 95% to be within 2, 99.7% to be within 3. Okay, so this data point here could be a bit of evidence that it does not follow a normal distribution. But because it doesn't break any of the Western electric rules here, it doesn't break the 3 sigma, and it's only 1. Again, there's a bit of a area of judgment here, but because it's only one of the data points here, let's leave it in. But in reality, there is some degree of judgment that you need to make on this as to what you keep in and what you remove to determine business as normal. But that one we'll leave in. Okay, as I mentioned here, we can run the Shapiro test to sort of manually to check, do a hypothesis test, and you notice that that this when we do the normality test here, the p-value is above 5%, and that indicates that it's that it appears to follow a normal distribution. Okay, so yeah, we've got one data point here, but amongst 36 data points, what this is sort of saying is that you'd expect to maybe get one data point that's a bit unusual, that's consistent, but it is a bit far out, so it's a bit of a worry, but the hypothesis indicates there's not enough evidence there to conclude that it does not follow a normal distribution, so we'll just let that lie. Clean up a data frame, clean up the console by pressing Control L. Okay, and that's probably I think that's I should go through some sort of others as well. So So this one is going to be an R and a proper X bar chart for the flavor, looking at the flavor additives. So let's sort of load in the data and have a look at it. Okay, so here we've got some samples that have been taken, and you can see that there's 4 samples taken for each period, and I've just loaded that up there. And for doing the R chart, because we know we should do an R chart before we look at an X bar chart. Remember the R chart tracks. Let me just get rid of these. The R chart tracks the maximum minus the minimum values in any particular sort of sample or subgroup. So the maximum here is 83, the minimum is 50, so the range here is maximum minus minimum, and it's 33. Okay, so that's what that first data point is representing here. It's sort of 33 is the spread, the range, the maximum minus minimum. In the next one, the maximum is 89, the minimum is 70, so the spread there is 19. So you can see there, it's just sort of 19. Okay, so just a little below 20 there on the axis there. Okay, so that's what the R chart is plotting, and you're looking for the minimum on an R chart is normally, for the lower control limit, that's normally set at 0. So we're normally looking for violations of the upper control limit here as indication that something unusual is going on, and there doesn't seem to be any significant problems here. Let's have a look at the X bar chart. Now, for this one, for an ordinary X bar chart, you just use the X bar as the type. Use the X bar dot one if you're trying to get it to do an individuals chart. But apart from that, it sort of works the same. So, okay, now that hash, by the way, that's just my notes, so it'll be ignored. Now, if we look at the X bar chart, we've got some red dots up here, so we've got some violations of the upper control limit. So it looks as though sample 2 or subgroup 2, subgroup 5, they both got problems. So subgroup 2 and 5, they've both got pretty big range. They've got sort of particularly higher than average sort of values there, which could indicate that something special is going on. It needs to be investigated. Okay, now in terms of sort of cleaning this data, what we're going to do for the clean data here is, well, let's just load it up. I've done the clean data for you here. Okay, so let's load it up and have a look at it. Okay, we can look at it just by clicking on this. Okay, so what we've done here is remove the ones that appear to be sort of unusual. And we've got sort of the first 5 there seems to be all sort of pretty wacky. So what I've done with this one is actually I've just ditched all of the first 5 from the sample, and we're just running from 6 to the end. So notice here, sort of look at the first one here, 56 to 75. 56 to 75. So we've just dumped those first 5 because it just seems to be really unusual there. It's perhaps a calibration period, and this seems to be much more like business as usual. Okay, and remember, when we're in phase 1 and we're trying to work out sort of the center line upper and lower control limits for business as usual, you want to get rid of unusual data there, and there looks to be some sort of calibration that's going on there before the sort of the normal business process sets in. Okay, so we've done that. Because we've dumped 5 data points, we need to sort of reset up our labels here. So let's create a sequence of numbers between 6 and 20. Now these I didn't actually read from the file because I didn't put those in there. That X bar chart, when you're using the X bar chart, it tends to just read all of the numbers in there. So if we put sort of 1, 2, 3, 4, 5, etc., it'll sort of read that in as one of the values in the sample. So we didn't want that, so we just sort of we've just only got the particular values in there. So to create these values for the axis here, we want numbers from 6 to 20 because we're ditching these 5 data points. We've created a variable called label, and it's a sequence of numbers between 6 and 20. Okay, so that's how to manually do that. Okay, so let's generate the control chart, the R chart now, just on that. So if we do our R chart based on that, it's all looking good. And notice the horizontal axis starts from 6 and goes all the way up to 20. And if we do an X bar chart, it should be looking much better now. Cross fingers. Much better. And the center line is actually quite different, notice. After removing those special causes, the center line before, when you had this sort of calibration data at the start, was at 63. But now that we've sort of removed those unusual cases, the center line is now much lower at 59. The standard deviation has fallen to 7.9 here as well, whereas before it was 9.08. So what's happened when we removed those special causes, it actually lowered the center point and actually decreased the spread as well, which will change the control limits. Okay, so we'll get rid of those variables, and let's close up our charts. Which there's a few of. Sure, there's probably a way to do that as a shortcut to get rid of all of them. Okay, now let's have a look at generating a p-chart. So, and we'll do that with some data on tracking the proportion of rescheduled jobs that needs to occur. And let's have a look at that. Okay, so in week 1, we've got the sample that was taken. There's 250 jobs that were in the sample, and it's the number, sort of the days sort of spent on the rescheduling. I can't remember the exact details for that exercise, but this is the number of days in the that was required for rescheduling, or something along those lines. So to do a p-chart, now remember with p-chart, there's no ancillary chart to do. Remember with x-bar, you do the r chart first. With the I chart, you do the mr chart. Well, if you're doing a proportions chart, which is the proportions of fails, there's no ancillary chart to do. So just run the p-chart directly. So the command to do that is, again, using QCC. The type is a p. We need to feed in 2 variables for a p-chart, which is, well, the number of fails and the total sample size there. So that's what I've done here. Grabbed the reschedules data frame, grabbed the days as the number of fails, or the days being sort of the number of fails, and the total in the sample. So, okay, so what the QCC chart will then do is basically divide that number by that number to work out the proportion of fails. But it's actually quite important. You need to actually give it the number of fails, because for this p chart, the upper and lower control limits, the formula for those control limits requires little n, which is your sample or subgroup size. So we need to give that number to it as part of the function, so it can calculate those upper and lower control limits. If we do that, we see that week 6 was an unusual number. It's breached that upper control limit. Let me get rid of those. So week 6 was an unusual one here, 30, and we can see that visually there. It's pretty bad. By the way, we don't have much data for this one. There's only 10 weeks, which isn't particularly good. Preferably it should be 20 periods of back data. But now, one of the requirements here is that the average number of fails is actually 5. So you'll notice here that you don't even need to calculate the average here. You can just have a look at those numbers and see that the average is well above 5 there. So we've got that, but otherwise you can just use calculate a mean of that yourself. We did that in the understanding data topic on how to do that. Okay, and that's pretty much it for that question. So you've got an example there of a p-chart. Now this is another sort of p-chart example. Now it seems to be pretty similar here, so I'll let you work through that yourself. Is there anything different here? Got the cleaned, or we can generate the clean data ourselves. So yep, no, I'll let you do that. I want to give you an example of a C chart, so you can see an example of that. So this one is looking at people's sort of outstanding leave, annual leave. So if we have a look at our data here, we've got sort of the pay, sort of particular pay period, and sorry, it's actually number of complaints. It looks like need to sort of check the details of each of these. I forget them. So we're registering some kind of number of complaints. I'm sure you can read that by reading the exercise question itself to see all the backstory behind that. Um, so we've got just our time period and the number of fails effectively. Now remember, this often when you're tracking the number of fails, you won't actually have the total number of like possible sort of passes or fails. You just get complaints and you're tracking the number of complaints. So you don't necessarily know if it's a customer data, you don't necessarily know how many people were using your product or your website on that particular sort of day or hour. You don't, but you do track the number of complaints. Okay, so that's what the C chart is really useful for. If you do have the total number of customers using your service at any particular time and can record the number of fails, then you'd want to do it as a proportion, like a P chart, like to track the percentage, because it's a better control chart. But if you can't calculate a percentage, you're only tracking an absolute number of fails, then you do the C chart. But the assumption here, though, is that the number of customers or the number of possible cases isn't growing over time, because otherwise you'll end up with this upwards trend, and you'll breach the control limits pretty quickly, and also it'll register a trend in your data, which is one of the violations of the Western Electric rules. But you just basically load in your data and say, well, we're tracking the complaints. Oops, I just stuffed that up. We're tracking the leave data, tracking the number of complaints. It's C chart, and the rest is sort of saying adding statistics, and add an X label, a label for the X-axis, and a label for the chart. So it does the C chart. So I've got another example of a C chart down here. So okay, so that should pretty much get you going. There's quite a few examples in there, and obviously you don't need to do all of them. Just make sure you're sort of reasonably familiar with how to generate these control charts in R, because it is a really powerful piece of software for generating these. And in a company, the nice thing about R is that you can script it. So a lot of your programmers, they don't know statistics because it's not taught in a computer science degree. But you can actually teach a bit of control charts to them and explain how they work. They're usually pretty clever and can work it out pretty quickly. But it means you can automatically generate those. They can just sort of automatically run queries of your database, sort of pull the data, and then use R and automatically generate these control charts, and then run a script that will generate sort of emails to key people, or it might update sort of a JPEG image of this on a particular dashboard that staff are looking at, and it just sort of keeps that information up to date. So it's useful. It's a really useful piece of software to be able to generate those automatically. And as I mentioned, the nice thing about R as a piece of statistics software is that one, it's powerful. It lets you do some really, it doesn't impose a ceiling on you, and a low ceiling like Microsoft Excel does. There's a real limits to what Excel can do, and that ceiling's pretty low. So you don't have that same ceiling in place with R. You can just keep going with your data analysis knowledge and statistics knowledge, and R will be a good companion along the whole journey. But it's also because in a company, it's open source, it's free, easy to implement. You don't need to get some kind of authorization from finance to sign off on $1,000 stats package per seat. It's open source, anyone can download it, and the packages are being developed over time, and they're really sort of the package continues to be enriched over time, and it's scriptable, so it's easy to automate things from an IT point of view. So which is great for sort of keeping information on dashboards up to date. Okay, I think that's pretty much it for this sort of webinar. I hope it's helpful for giving some guidance on how to generate these control charts in R.